command here is what's called bit shift left. I'm actually going to take bits and shift them. I can shift them right, I can shift them left. I can shift them virtually any direction I need to. This is coming from the tab File, Shift, and Sequence. I can bit shift left, bit shift right. Okay, sequence left, right. We got all kinds of commands based on the type of CPU to use. Now, line number 0 is going to be my start. I turn on the switch, it activates the output. This output right there is going to activate the bits. Now, what I'm using here as an input to actually shift the bits is part of the CPU's scan time clock. This is from status bit number 4. So if I bring up my status files, I got a status file looks like this, which is troubleshooting the processor, but right down here in the radix, I have structured. If I change that to binary, I have a little bit different view. Now what I have here is I'm using status file 4, which is right here. This is the time base. This actually is the scan times of the CPU. And I'm using bit number 10. This is going to be about half-second mode, somewhere around a half a second. But this will turn from a 0 to a 1. And every time it turns to a 0 to a 1, okay, that bit right there is going to cause this bit to shift. Okay, B30 is going to be my binaries. So it's going to shift my binary tables. So if I were to take the binary table, I'm going to leave this up, it's going to take these bits on B30. That's this word here. It's going to start and shift the bits to the left by 1. Every time that bit shift left turns on and off, the bits are going to shift by 1. They'll turn from zeros to 1s. And when I drop the logic and turn off this switch on the top, it'll shift those bits back to zeros. So now we can have pretty much automation. Shifting, sequencing, these are often referred to, or they compared to, like a drum switch. You can run the same portion of a program or same equipment over and over. Very good for repeated process. Now let me go ahead and download. We download the file, put the processor in program mode. We're erasing the memory at this point, replacing it with a new program. We do not apply communications differences. Go back to run mode, go online. Well, what we have right there, it's already started up. I have my switch closed. But if I bring up my binary files, we're turning all these bits on, starting at B30 for a length of 48 bits. That happened pretty quickly. But as I turn this switch off, now I'm switching zeros from side to side. So I can shift zeros, I can shift ones, and this happens every time that time base turns on and off. I can shift these bits slowly, I can shift them fast, whatever it needs. For an automated process such as bottle line or punch press, this kind of system is very good. All these different types of commands help simplify in the programming process. A lot of different tools to be used. So we have bit shift. I can shift right, I can shift left. Same program, different directions. Same command. Now, difference here is we have the file right here. This is going to be the bits that are going to shift. Now, we're going to shift from B30, starting at B30, a total of 48 bits. The address that actually activates the shift command is going to be 0. Output 015. This is an output. When this output is activated, the bits shift from 0 to 1. When it's deactivated, they shift back to zeros. Now this is allowed because of a control file. This file allows the automation within the automation. It's called a control file. And under different types of programming, this file is going to need to be used. It has all different types of control points. It gets very complicated, but there you can see how that works. It's going to shift 48 bits, and the bits are enabled and they're done. Every one of these can be used as a control at one point or another for different types of automation within the automations. Very common to see this command.